Hi, I'd like to welcome you all here tonight to our second presentation from Storm Surge to help educate us and our community about the effects and implications of climate change and sea level rise. And just out of curiosity, I want to see a show of hands if this is your first lecture that you've attended or attended. All right, so maybe 20-25% of these people are new. So our last event was held at the Newburyport Public Library. All of our future events through the into the Christmas season will be held here at the National Wildlife Refuge. And the reason Storm Surge has formed is because we're a group of concerned citizens, and many of us are scientists and educators and project managers. And we're concerned about what's happening in our world around us and feel as though our communities need to start paying attention to what's going on so that we can adapt and make the changes necessary to accommodate what lies ahead of us. So part of that process is one of social change, which takes a long time. And we feel as though we need to educate the populace, stimulate a need in the populace to maybe put a little bit of pressure on their elected officials to start paying attention to this. And so we start with these educational seminars and lectures. So tonight we have Dr. Cameron Wake, who will be lecturing on climate change here in New England. We'll be looking at what's happened in the past, what's going on now, and what kind of changes we'll see in the future. And he's well qualified to talk about this. He's a research associate professor in climatology at the University of New Hampshire. And he's published some 70 papers in peer-reviewed journals on that subject and others. And I don't want to delay it any longer, but I'd like to introduce him and welcome him. And let's see what we can find out.
Well, really happy to be here with you this evening, and thanks for inviting me down. Hopefully it won't be too much lecture, a little bit of information, and then we'll leave plenty of time for you guys to answer questions. So I won't talk for too long, but I'll talk for a while. Before I dive in, actually, I really want to tell you the three things that you should know about climate change that I've come to understand after 25 years of studying it. And I'll show you all the slides and the data and stuff, but here's the main points. The first one is climate changes. Climate always has changed, and climate always will change. The only difference today is that humans are the main drivers of that change. And I can say that because there's an overwhelming body of scientific evidence that shows that that's the case. As a result, our future climate is literally in our hands. The climate that our children and grandchildren inherit depends fundamentally on the decisions we make today and over the next decade on how we produce energy, on how we use energy, and how we adapt to the new climate normal. So that's an important point, right? The future climate is literally in our hands. Most of you are my age or older in the audience, and we're going to be okay. It's our kids and grandkids that are really going to suffer as a result of what's happening right now. Second is, over 25 years, that climate change has become a distinctly moral issue for me. And I think of that in a couple of different ways. One is that it's the most vulnerable who are going to suffer the most. It is the old, the young, the weak, the sick, and the poor that are going to suffer the most. And for proof of that, you just have to look at the big disasters we've had in Katrina and Hurricane Sandy. And if you had resources, you were able to get out of town. If you were stuck in a hospital bed, you weren't. It's also true that I drove down here albeit a fuel-efficient car, but I emitted a bunch of carbon dioxide to the atmosphere. It's going to be around for well over 100 years. It's going to be heating our planet for a long time. So I get all the benefit out of burning that energy, and I put the impact on the children and the grandchildren. Last but not least, the third point is that it's really not about the economy versus the environment, which is often how this problem is set up. And especially in New England It's about the economy and the environment. We really have to work to replace the tyranny of the or for the opportunity of the and. And again, there's two ways I think about that. One is the weather disasters that are hitting us with Hurricane Sandy sort of topping, right? $65 billion. It's a lot of money. We've got to figure out how we can make our communities more resilient so that we save people's lives, we protect their quality of life, but so that we can rebound after the weather disasters that we're seeing. And that ultimately, if we invest up front, that's going to save us money in the long run. The other way to think about that is our energy security. The only way we can control how much we spend on energy is by controlling how much energy we use and where that energy is generated. So we should become more efficient and use less, and then we should generate all that energy in New England. And if we wanted to, we could actually do it. We have the technical capabilities to solve that problem. I've done the calculations more than once. We have plenty of renewables that we could harness to actually drive our entire economy and make us very comfortable. We just have to want to do it. Is it going to cost money? It's going to require a huge investment. And we have to figure out how we can get that money out of private markets and in helping our communities and make sure we can get a rate of return on that. But that's really the challenge before us. How do we improve our energy security? And how do we make our communities more resilient to the new climate normal? And I think if we actually go down that pathway, it would be really good for our New England economy, because you cannot ship those jobs overseas. And we have pretty much, I would argue, pretty much full employment if we invested in that. All right, so you can go home now. That's my three main points, but now I'll go through all the details. Just a couple, one slide to start. I'm actually by training, I'm an ice core paleoclimatologist, and I got to spend this past spring up on Denali. So this is like the picture of me with the beard filled with snow and ice. This is our drill site up in Denali National Park. There's Mount Foraker here. It's Mount Hunter right here, and down here in the distance you can see our drill site. We did a little bit of skiing, but we actually drilled 2 cores to bedrock in the month of May. Flew them out by helicopter, then by airplane, then by freezer truck, and then a federal facility out in Denver now. We just cut them up, and we're going to reconstruct climate change in Central Alaska for the last 1,000 years, where it hasn't been reconstructed. And that's the best site for any ice core scientist. That's the last piece of core from the bottom of the hole, where it goes from the clear ice at the top to the dirty ice right next to the bed. But I'm not going to talk about Alaska climate change. We're going to talk about climate change in New England. But I just wanted to provide a couple of introductory slides on where you can get really good climate information. This site is back up now that our government is back up and running. It's called climate.gov. It's really easy to remember. It's got lots of stories. It's a nice website. 16 different federal agencies contribute to it. But I really like it because it has all the data. And so you can go in and you can actually look at how temperatures change, or how solar energy has changed, or how sea levels rise, or how snow cover is changing, or how carbon dioxide levels are changing. So for your denier friends, if you want to get involved in an argument, you can probably do that. It's not too hard. But if you actually want to get involved in a discussion, you can start off by saying, hey, let's look at the data. All of the discussions I have with people tend to start, let's just talk about the data and see if we can agree on that. Because if you can't agree on the data and the science, it's impossible to have a discussion about how to move forward, in my humble opinion. So this is a great site if you don't want to sort of follow all the scientific literature. This is another very powerful data point. Every 4 years, the Pentagon produces a quadrennial defense review for incoming Congress. The next one's coming out in 2014. And in their last 80-page report, they dedicated 8 pages to the issue of climate change. And that quote, which I'll give you a second to read, sums up what they said in 8 pages in that report. You cannot separate our future security from the issue of climate change, and you can't separate our security from our economic activity, right? They're intricately linked. This is not a liberal think tank, right? This is an organization that's responsible for ensuring our security into the future, and they're beginning to act. And I'd like to see sort of that as a signal for the rest of our society to actually stop talking. We got to talk about this, but we actually have to start figuring out what it is we're going to do for the future. I'm going to have one piece of ice core information for you. I just want to set the stage. This is a really famous ice core record that comes from a place called Vostok in Antarctica. That upper picture in the left-hand corner is actually a picture of the Vostok ice core coming out of a barrel. And that one below it, that's kind of kaleidoscope of colors, is actually a thin section of an ice core viewed through cross polars. These hexagonal crystals here are the ice crystals, and these big blobs are actually samples of air that are trapped in the ice as the snow transforms to ice. So when we drill an ice core, we go back in time, we pull it out, we actually can capture samples of the atmosphere that have been trapped in the ice core lattice. We crush that ice, we suck that air out, and we can measure the trace gas content back 420,000 years ago. That's pretty cool. That's like a cool scientific experiment. So we've been able actually to track the carbon dioxide level in the atmosphere for back 420,000 years. And there's something, hopefully you see this sort of 100,000 year cycle here, right? Current interglacial, last glacial here, 18,000 years ago, right? There was nothing living in Newburyport or Plum Island 18,000 years ago. We're covered by a mile of ice here, right? Sea level was 400 feet low. It was a very different environment. The glacial lasted about 90,000 years, and there was a previous interglacial. You can see that 100,000 year cycle of glacial interglacial cycles, driven primarily by changes in the Earth's orbit around the sun that changed the amount of radiation that the northern hemisphere received. That drove this vicious cycle of, I call it an ice albedo feedback loop, which you can ask me about if you want to know more. The real important point I want to show you is carbon dioxide has never been higher than 300 parts per million by volume, and never lower than 180 parts per million by volume, making the Earth a pretty nice place to live. So thank the ecosystem when you go outside for keeping carbon dioxide between these levels. Right? So along come human beings, and we figure out that we can burn carbon from the crust. That gives us all the energy that we've actually used over the course of the last 150 years to do incredible things. But there's this byproduct called carbon dioxide. So that blue line represents the increase in carbon dioxide in the atmosphere since we started monitoring it directly in 1957 in Hawaii by a scientist called Charles Keeling, who figured out how to convince his PhD advisor to send him to Hawaii to do his PhD research. So you can see that we have already increased the carbon dioxide content of the atmosphere an amount that's similar to the transition that we see between the glacial and interglacial age. All right? I have to show you no other piece of evidence to tell you that humans are dramatically changing the Earth's climate system. Right? There is no doubt. Why do you care about carbon dioxide? Because it's just like a blanket that you put on your bed on a cold East Coast winter night. It's not like a greenhouse. It's like a blanket. That blanket helps trap long-wave radiation coming from your body. Greenhouse gases in the atmosphere trap long-wave radiation coming from the Earth. We figured out the physics 50 years ago. You put more carbon dioxide in the atmosphere, it's going to get warmer. Basic physics. So when I first came to New England, I actually learned an interesting Yankee saying that usually parents use for their kids that goes something like, if you're not careful, son, daughter, you're going to end up where you're going. And that's exactly what's going to happen with greenhouse gases in the atmosphere. If we continue to rely upon fossil fuel as our main source of energy, by the end of this century, we're going to end up with carbon dioxide levels at something on the order of 1,000 parts per million by volume. That's going to result in catastrophic climate change. Conversely, if we invest in energy efficiency and renewable technologies and exporting our American can-do spirit around the world, which we're not doing right now when it comes to energy efficiency and renewable technologies, we could level out by the end of the century somewhere at 400 to 450 parts per million. That's certainly going to result in some climate change, but likely climate change that we can deal with and adapt to. So that's where we're going, that's where we need to be, and the difference is the challenge that our kids and grandkids face. Just a couple of other global pieces before we dive into climate change in New England. This is a record that has really taken the scientific world by storm. And if you've been paying any attention, you've probably heard about it in the newspaper as well. So this is the amount of September Arctic sea ice extent from 1979 to 2011. So this is the satellite record of sea ice extent. So you can see the y-axis, the vertical axis on the left-hand side is million of square kilometers. And you can see that the blue line tracks this long-term decline in the amount of sea ice that's around at the end of the summer. So why do you care about Arctic sea ice? Because it's white. And it reflects incoming solar radiation. It's a really important component of the Earth's energy balance. When you remove that sea ice, what's left is dark ocean that absorbs most of that incoming solar radiation, and it heats up a lot, making it really difficult for the sea ice to form in the winter. So we've seen this long-term decrease in the areal extent. It's also getting quite a bit thinner. There's not as much multi-year sea ice. But then we had this crazy year back in 2007 when we lost a lot of the multi-year sea ice. So there was 1 year thick sea ice, which is 10 to 20 feet thick, and we had a really warm summer, and we had a decrease of 25% of sea ice at the end of the summer in that 1 year. And then it happened again in 2012, and it's rebounded a little bit this year. But we're essentially going to see the loss of Arctic sea ice sometime in the next decade or two, maybe 3. And that's not coming back because the Arctic Ocean is heating up. So we've sort of crossed that tipping point. It's going to disappear, and we have to deal with it. If you actually talk to your denialist friends, they'll say, well, it rebounded in 2012. Let's not worry about it. But that's because 2012 was a cold year. So there's always going to be year-to-year variability, but we're on a long-term decline. The other thing that my denialists, what I read on the web, is that, well, don't worry about it. It's going to come back in February. It's like, we don't really care about Arctic sea ice in February because there's no sun in the Arctic in February. It's not really affecting the Earth's energy balance that much. And then in case you've heard about, read some newspapers about the global warming pause, like it's not warming up anymore. Well, here's a decadal average of temperatures going up through 2010, and you can see that we continue to warm. What's happened over the last 4 to 5 years is that more of that energy is in fact going into the ocean. So that red line represents the world ocean heat content from 0 to 2,000 meters, and the black line is even the deeper ocean, right, 700 to 2,000 meters, and you can see that those temperatures are just continuing to go up. Now, this is measured in heat content because the ocean contains, and it's a huge flywheel, right? It's a huge thermal mass, so it doesn't go up a lot in temperature, but small temperature relates to a huge heat content. So let me just put that into context for you. Where is global warming going? Right? Almost 94% into the ocean. So we see little blips in atmospheric temperature, but it's really the ocean temperature that we want to pay attention to, and look at how the ocean is heating up, right? Continuing to heat up in a significant way. So that's where the warming is going. So let's turn to New England. I guess the real question I'd like you to consider is, were you ready for the storm? And there's not any one particular storm I want to point to. It's any number of storms, and you can add the ones that I don't have up here. But this is one, Snowtober, right? About 2 years ago, when we got a foot of snow right before Halloween, when the oak leaves were still on the trees. And the utilities, right, got hammered by the regulators because they weren't ready for a storm that dropped a foot of snow at the end of October. So when have we ever had that before? Right? Hasn't happened. We weren't ready for it. We had big flooding in 05, 06, and 07 from springtime storms. One of the pictures up there from Newmarket, New Hampshire, that got really badly flooded. We had Irene, which obviously did considerable damage across Vermont, and then Sandy down there in the right-hand corner. So this is very much the new climate normal that we need to be prepared for. And I'm going to ask you the question again, right? Are we prepared? I would say that we're not. What we're really prepared for, what we're really good at in New England, is getting rid of snow from nor'easters. So if you don't believe me, go to Washington sometime and there's a big snowstorm, and they can't figure it out when there's 4 inches of snow on the ground. They can't plow it, they don't know where to put it. There's taxis stuck in the street, nobody wears boots. It's like, what's wrong with you people? In New England, we figured that out into our municipal budgets, our county budgets, our state budgets. We bring in salt all summer and sand. We are prepared for nor'easters and storms, and that's what we need to start doing for climate change. It needs to be a decision that we make in our family budgets, in our community budgets, in our municipal budgets, in our county budgets, and in our state budgets to deal with the change that's going to happen, and not just deal with it in the aftermath, but actually prepare for it so the impact is much less. That's probably my main message for tonight. All right, let's talk a little bit about the Northeast. I'm not going to show you all my data because it would take weeks. I'm just going to show you a few highlights. This is by far the most dramatic change that we've seen in any single indicator that we look at across the Northeast. And it's an increase in Northeast winter temperatures across the entire region. So the blue line represents year-to-year temperature variability, and the red line represents the long-term, century-long trend. and then the trend over the last 5 decades. So what you can see is there's a long-term warming, but really the rate of that warming has doubled over the course of the past 5 decades. You can also see if you don't like a winter, right, wait, because the following winter is going to be way different, right? And we know that in New England. Our weather varies year to year considerably, but long-term significant warming and a really increase in the rate of change. So if I take that linear trend over the last 50 years and I plot it as a dot on this map, there's the trends from all the stations that make up that previous plot. But you can see that we're looking at an increase of 3 to 4 to greater, 3 to 4 degrees Fahrenheit or greater temperature increase over the last 5 decades, right? This is not climate change in the future. This is what's already happened. And it's clearly related to the dynamics of snow cover. So you get a little bit of warming, you get a little bit less snow cover. That snow changes from white snow to brown ground, and that brown ground absorbs more incoming solar radiation and heats up and melts more snow. So this is a very particular mid-latitude signal that we're experiencing, and our winters are warming up as a result. There's also, I love to play, I love to ski, I love to drill ice core, and I love to play pond hockey. I love living in New England as a result, and so I'm really concerned about the loss of all the ice that we have in our ponds and our lakes. Here's 2 really long-term records from Lake Winnipesaukee on top and Lake Sunapee on the bottom. And you can see since about 1970, that says on top, you can't see it, ice out dates. So when the ice actually leaves. And you can see that it's happening earlier and earlier over the course of the last 40 to 50 years. When I was up at the Pond Hockey Classic, here's my team here, that's up on Lake Winnipesaukee. Last year was great, but the year before, on February 1st, the ice had not come in on Lake Winnipesaukee and Meredith Bay, so we had to move the entire tournament. This isn't a small tournament, this is 1,500 people playing pond hockey for a weekend, and they had to move it all to another lake. So I'm sure if you've been paying attention, you've seen that the ponds around here don't freeze like they used to. So another indicator is changes in extreme precipitation event. Durham, New Hampshire is where the University of New Hampshire is. What I've got plotted here is 4-inch precipitation events that occur in a 4-hour period. So these are really big rain events. On the bottom, I've plotted number of events per decade. So 1948 to 57, 58 to 67, and so on. And what you see is that the number of events essentially has doubled over the course of the last decade. I first saw this, I said, I can't believe it. Somebody's been messing around with the Durham Met record, they haven't been paying attention. But Lawrence, Massachusetts, it's exactly the same, right? It's same here in Newbury, but you guys just don't have a Met station, right? You're getting way more rain and fewer events, and that rain is falling on a watershed that's got more impervious surface because we've developed it in a big way over the course of the last 5 decades. So you're getting bigger floods because there's more rain, and more of that rain is running off into the river, resulting in more flooding. Another way to look at how climate change has affected the region is to look at what the New England states have actually asked for from the federal government in terms of presidentially declared disasters and emergency declarations. And so, I've got different colors for different states, but you can begin to see a real change here with the flooding events that we had in 2005, and Massachusetts suffered quite a bit in this. New Hampshire in green, 05, 06, 07. Big flooding events. Irene in 2011, you can see Vermont over $200 million. But this isn't solely a result of climate change. This is climate change interacting with communities that have made themselves vulnerable to that changing climate. We have not been building our infrastructure so our communities are resilient. We've been ignoring it. And as a result, we're seeing more and more damage as our storms are getting bigger and bigger. So that's going to be a key indicator to track as we go forward in the future. I would also add that this pales in comparison to what happened with Superstorm Sandy, right? $65 billion versus we're talking at the most, right? $500 million. Let's not hope something like Superstorm Sandy hits our coastal New England. It's bound to come eventually. Our 1938 storm is around the corner somewhere, just with a lot more sea level rise. Here's how sea level's been changing. Portland, Maine, Boston, and New York, going back to 1850. You can see that there's this steady rise, about 7 to 8 inches over the course of the last 100 years. Boston and New York are particularly vulnerable because the land is actually, we have coastal subsidence, while the volume of the ocean is increasing. We're a little bit better sort of here going north, but you guys are certainly well aware what's happening out on Plum Island in the houses there as a result of sea level rise and big storms. All right, so we've already seen considerable climate change. So I want to spend the rest of my remarks talking about how climate might change in the future, and this comes from a number of different studies. One of them is the Northeast Climate Impacts Assessment from back in 2006, 2007, and you can get all the results I'm going to show you at climatechoices.org. And then more recently, I've been working with a group of really good scientists to develop a number of different regional or watershed-based regional climate assessments. So we've done one for Casco Bay, we've done one for Great Bay, I'm finishing up two for New Hampshire, and over the course of the next year or two, we want to go back and revisit and do it actually for watersheds across New England. So stay tuned for that. I started off by saying the future climate is literally in our hands. And so this is a graph that sort of shows you that. We can't possibly predict what our economy is going to look like next year, next decade, let alone 90 years from now. So we're not foolish enough to try. Instead, what climate science and climate scientists have done is really develop a set of plausible scenarios. Think about them as storylines, things that could happen, not necessarily things that will happen. And it's a way for us to actually begin to think about the problem when dealing with significant uncertainty of not knowing what our economy is going to be like. So this was done by the Intergovernmental Panel starting in 2001, and they did it in 2007, and in their recent report that just came out. But what they've said is, let's look at a bunch of different scenarios. And I'm just plotting two of the many scenarios that have been developed. One is the high emission scenario, that's in red. So what you're seeing here is numbers that represent carbon emissions associated with a population, socioeconomic, and energy future. Storyline that they've developed. Population grows to 9 billion people by the middle of the century, which it almost certainly will. We behave a little differently in the developed world in that we actually spend a lot of money to bring the developing world out of poverty, but a lot of that elevation out of poverty comes with them burning fossil fuel. So greenhouse gas emissions take off because the developing world is burning a whole bunch more energy, even as we're becoming more energy efficient. The low emission scenario, and you can see this is global CO2 emissions, billion metric tons a year on the bottom. The low emission scenario, same population and socioeconomic scenario, the only difference is we get our energy through first energy efficiency, so we cut our demand for energy by about 50%, and then we produce that with renewable sources. And you can see that our greenhouse gas emissions begin to drop by the middle of the century and then go down. Concentrations in the atmosphere continue to rise because carbon dioxide has a lifetime of more than 100 years in the atmosphere. So then we take those numbers and we use those as drivers for these tools science has called global circulation models or general circulation models or general climate models, depending on who you listen to. And so we can look at what the outcome of the two different emissions of carbon dioxide are based on temperature and precipitation with these models that actually essentially reconstruct how the Earth's climate system works. What we do is we take the output from these big global climate models and we statistically downscaling it using historical data to develop a relationship between a big grid cell and a whole set of meteorological stations on the ground. So we do that so that we can better understand sort of smaller scale changes. And if you want to know more about that, we can get into the technical details. But it does a pretty good job at reconstructing climate over the training period. So I'm going to talk a little bit about how our temperature and precipitation might change in the future. So here's temperature. Going from 1900 up to 2100. The black line is the historical record. The red line represents the higher emissions scenario temperatures, and the orange line the lower emissions scenarios. Three things from this. One is the models actually capture the warming we've seen over the last 4 to 5 decades. That's good. Global climate models are capturing what's going on in the Northeast. The second big point, by 2050 or 2040, there's no difference between the two curves. What does that tell you? It is unlikely that, I would say it is very likely that our temperature is going to go up by an additional 2 to 3 degrees Fahrenheit. There's no difference between the emission scenarios. And that's happening for two reasons. There's incredible inertia in the climate system, and that carbon dioxide lasts for a long time in the atmosphere. So you can't solve the problem in a short period of time. So that is an amount of warming that we are already committed to, and we better start preparing for, or it's going to cost us a lot more money even if we prepare for it. Last but not least, you'll see by the end of the century that there's actually very different amounts of warming, and that happens if globally we can transition our energy system over the next decade. And the reason it has to happen over the next decade is that once you begin the transition, it's going to take 30 to 40 years to transition that energy system, which also is like a proverbial supertanker that takes forever to turn around. You can't just stop producing energy with fossil fuel and do it all with solar. It's going to take incredible investment, lots of hard work, but we got to start today so that by the end of the century we have warming that we can adapt to as opposed to warming that's catastrophic. So what does that really mean in terms of temperatures? So we tried to put this in what we call our migrating state map. So there's Massachusetts up there, 1961, 1990, summertime temperatures. How hot will Massachusetts feel in the future? Well, under the high emission scenario by the end of the century, Massachusetts summers will feel like they currently do in South Carolina. Conversely, if we follow a low emission scenario, Massachusetts summers are still going to feel like they do in Baltimore and Washington, D.C. Let me put that into perhaps a more stark contrast for you. Currently, in Boston, Massachusetts, you guys are probably a little cooler here than they are in Boston. They currently experience 9 to 10 days per year that feel as though they're above 90 degrees Fahrenheit. Those are the really uncomfortable days, usually that have bad air quality associated with them when we're all running our air conditioners. And I know that because the biggest energy demand in New England is now in summertime because of us running all our air conditioners. By the end of the summer, under the high emission scenario, we would expect there to be 65 days per summer that were hotter than 90 degrees Fahrenheit, which means summers would be a heat wave, right? 2/3 of the summer would be above 90 degrees, punctuated by slightly less uncomfortable days. Conversely, under the low emission scenario, we're still looking at 30 days per year that are above 90 degrees Fahrenheit. So it's going to get hotter. We're going to have probably a lot more premature mortality as a result of heat stress, probably something we need to start planning for and preparing for. Projected changes in extreme precipitation. I'm going to encourage you to just multiply these numbers by 10. I couldn't find my other graph when I put this together, but just think of that as 2, 4, 6, number of events per decade. So you can see for all the stations I have here, right? Concord, New Hampshire, Durham, New Hampshire, Lawrence, Mass, Portland, Maine. You just put Newburyport in there. We're looking at a significant increase in the number of these events from what have happened in the past, sort of 2 to 3 to 4 per decade, to essentially 10 to 12 to 14 per decade. Right? We're going to have more big precipitation events in the future. And that rain is going to fall on watersheds that have more pavement in them and likely more impervious surface unless we develop our watersheds differently, which we can and we technically know how to do. We just have to do it. But if we continue on business as usual, the floods are going to get ever bigger and bigger. We look at output from a whole bunch of different models, and really they all say the same thing: more rain in fewer events. And the reason is because warm air can hold more moisture. So when we do have precipitation events, there's more moisture in the air that can come down. Actually, I want to share one research project I was working on in the Lamprey River, where we actually mapped not only how the 100-year flood change, the 100-year floodplains have changed in the historical period up to till today, but how they might change in the future. So we looked at the Lamprey River watershed, which drains into the Great Bay. It's in southeastern New Hampshire. It's about 214 square miles. And what we did was two things. We looked at how future climate was going to change. We looked at output from a whole bunch of different models, and we said the biggest precipitation event, the design storm that most engineers use now for coastal New Hampshire is the 100-year storm. How much rain will a 100-year storm drop in a 24-hour period? And that used to be 6.3 inches. It's 8.5 inches today, and our model suggested that the highest number would be 11.4 inches in the future. So we took that change in climate, and then we also built out the watershed. So this is how historically residential development has occurred. So that's up to 2006, when we sort of plotted an exponential curve through that in terms of residential development. So close to 50% of the watershed is developed, and then we did the same with significant commercial and industrial growth. Do we know this is going to happen? Absolutely not. It's a plausible storyline. You can compare today as the best case scenario to out there as almost the worst case scenario. And then we redrew the 100-year floodplain maps in the same, we used the same methodology that FEMA now uses to draw these floodplain maps. It's hard to see, but we developed a set of these maps for all the communities. The old floodplain map, actually, it's hard to see, but it's here in blue, shaded. The pink is what it is. So this is the legal floodplain map. The pink represents actual floodplain today, and the orange represents what it would be 100 years from now. So that's not very impressive. That's hard to see. So I'm just going to summarize the results for you. When we look at the changes from the flood insurance study, which is the current legal floodplain maps, to existing conditions today, about 2005, that was the latest land use that we had, we saw that the discharge of the USGS aid station at Packers Falls during the 100-year storm, if you've seen a river during these 100-year storms, you know that they're raging, right? So that discharge has gone up by 56% already. The water surface elevation has gone up 2.7 feet, so it's going over the bridges now. And the 100-year floodplain area increased by 20%. If you start thinking about where we like to build our houses and our businesses, next to rivers, that's prime land for building, it's prime land for agriculture, and you can see we're losing 20% of it. That's already happened. And then if we look out to the future, 2005 to 2100, we see an additional increase of 66% above that 56%, an additional increase in the water surface elevation of 4.4 feet. So it's going to go up 4.4 plus the 2.7, right? 7.1 feet, and an additional loss in floodplain area of 14%. Our message to the communities is you need to begin planning for this. What are you going to do if you put a whole bunch of buildings in these areas and they all fail? So maybe that's been okay in the past because we didn't know, but now we know. So let's figure out how to solve this problem and not make our communities more vulnerable, but make our communities more resilient. This is not easy. That land is worth a lot of money. There could be a lot of profit that's lost by not building on this land in the short term. There's a lot of money that can be saved and probably lives saved in the long term if we actually think about how it is we're going to deal with this problem moving forward. You can imagine, I might get depressed thinking about a lot of this information. So small victories are wonderful, and so on the page 7 or page 8 of the application for an alteration of terrain permit in New Hampshire, they have actually changed this checkbox. So it used to say rainfall amount obtained from the north, not from, it used to say TP40, Technical Paper 40, which was the NOAA official publication for the 24-hour 100-year design storm, which is really old and ended with using data in 1963, but what most engineers use to say actually go to this new Cornell Precipitation Atlas, and that's where the new 8.5 inches of the design storm actually comes from. So if there's one thing you walk away from tonight, if you're involved in any kind of infrastructure development, please make sure that the engineers at least do the designs based around the Cornell Atlas and not just TP40. They'll be impressed that you actually know both of those names. As a result of our study and other studies, New Hampshire DES actually changed its permit process, which we hope will actually save us a lot of money and suffering in the future. All right, so more precipitation, it means we're going to have more water all the time, right? Not so true. So because our summers warm up and summer precipitation doesn't go up much, it turns out that not only are we going to get more floods, but we're going to get more drought. So if you just focus on the left-hand column there, the one that's on top of the 1 to 3 months. So the top figure, you can't see it, but it says 1961 to 1999. That's the frequency of drought in a 30-year period. And those lime greens sort of represent about 10 to 15 droughts in a 30-year period, right? Typically, New England suffers a drought, short-term drought, in summertime, once every 3 to 4 years. Right? We haven't really had a significant drought recently. Under the high emission scenario, by the end of the century, you can see that almost all of New England is pink. That means we're having 30 droughts in a 30-year period. And this actually, the way that we figured this out was we actually modeled soil moisture. So it's inputs of precipitation minus outputs via evaporation. So it was a very sophisticated study. 30 droughts in a 30-year period under the high emission scenarios. That's a drought every summer, which I would argue New England is not at all prepared for. Under the low emission scenario, we can see a slight increase in the frequency of drought, but one that we could probably adapt to certainly much more easily. Our forests are also going to be changing. We have predominantly a maple beech birch forest. Just, you guys are probably in the height of your colors with maple leaves down here. No? Yes? Yeah. I was just up north this weekend and all the leaves are gone up there. And then the North Country actually is dominated by a spruce fir forest. Our forests, in terms of recreation and forest products, at least when we did this study, accounted for $19 billion annually. It's a big part of our economy, especially as you get farther north in the region. Under the high emission scenario, we would expect a climate that would no longer support a spruce fir forest anywhere in New England. And most of our maple beech birch forest would be isolated to the northern parts of the region and replaced with an oak hickory forest. So that's this image down here. And under the lower emissions, we retain most of our maple beech birch forest, but still lose the spruce fir forest. I don't know if there's a lot we can do to prepare for that, but I would argue that we really don't want to lose our maple beech birch forest. So let's figure out how we get on a low emissions pathway. In addition, if you haven't been paying attention, but I bet you have here in Newburyport, there's this new pest that's arrived called the Hemlock woolly Adelgid, that when it gets on hemlock trees, it literally sucks the life force out of them, and hemlock trees die in 3 to 4 years. So it turns out that their geographic spread is limited by one really cold winter night. Minus 18 degrees centigrade will kill them all off. We're not getting those cold winter nights as frequently. And so by the end of the century, we especially see a lot of warming and minimum temperatures in winter. We would expect Hemlock woolly Adelgid to infest, in fact, all of the forest across the Northeast, which would have a significant impact on our hemlock forest. And, you know, Hemlock woolly Adelgid isn't the only pest we have to worry about. They're not all linked directly to climate change, but warmer climates seem to be helping out equine tick disease and equine triple E and West Nile virus. So, you know, one of the big unintended consequences are what pests we're going to have to deal with in the future that we haven't had to deal with in the past. And then, not last, another big thing we looked at in this Northeast Climate Impact Assessment was marine resources, and we looked at the potential loss of the commercial cod fishery, which some of my fishing colleagues would say we've already lost. They've certainly lost it in Canada. But what we see here is that the thermal young juvenile cod need cold bottom temperatures in order to survive. So currently the thermal habitat for juvenile cod exists in the Gulf of Maine, but not in the Mid-Atlantic Bight. Mid-Atlantic Bight still has cod, just no juvenile cod. But by the end of the century, under higher emissions, we don't see thermal habitat existing for young cod anywhere in the Gulf of Maine. And therefore, we would expect the entire collapse of the cod fishery, sort of to, you know, layer it on top of 400 years of extracting resources from the Gulf of Maine as well. And then one of my favorite pastimes, skiing. We looked at this, we really sort of, we took a lopsided approach to this. We said, first of all, we said if ski areas are going to remain viable, they should be open for 100 days a year, which is a pretty good rule of thumb, and 70% of the time they should be open at Christmas. And then we allowed the ski areas in our model to make as much snow as they wanted. So there was no restriction, financial or water resources, on the amount of snow that they could make. The only restriction was it had to be cold enough. Right? They're getting pretty good. They can make snow almost right up to 32, maybe sometimes 33 degrees Fahrenheit. And then we went out and looked at temperatures by the end of the century, and we modeled this ski area by ski area. So north-facing slopes, you know, survive a little bit better. But the only area that remains viable for skiing at the end of the century is the mountains in western Maine, which means they meet both of those criteria. Everywhere else is either vulnerable or highly vulnerable, and the impacts are certainly much larger on snowmobiles as a recreation, because you just can't make snow for thousands and thousands of miles. So they suffer even more dramatically, which really you think would be, represents the collapse of winter recreation, at least commercial support for winter recreation across the region. Here's last but not least sea level rise, which I'm sure you all in Newburyport are paying attention to in Newbury. When you look at that curve, I hope you see that there's a lot of uncertainty in the future of sea level rise. Right, so here's how it's risen so far, global sea level rise. This is from a paper by Vermeer and Ramsdorff. There's about 4 or 5 papers out, and they have sort of similar levels of projected sea level rise. This was the Intergovernmental Panel on Climate Change, estimated sea level rise from their 4th assessment report back in 2007, and the 5th assessment report is now up in that range, the report that just came out. But you'll see by the middle of the century, something on the range of 1 to 2 feet of sea level rise. By the end of the century, 2.5 to 6, 2.5 to 7 feet of sea level rise. So if you're a policymaker and you've got to make a decision, or let's say you're the Admiral of the Navy and you have to make a decision, or you're head of the Army Corps of Engineers and you've got a whole bunch of infrastructure that's at sea level and you have to make a decision, this is a little disconcerting. Like, you scientists, can't you get your act together and figure out how much more, can't you narrow the bands and tell me actually how much sea level rise is going to happen? So it turns out we can't, because we don't know what's going to happen with Greenland and Antarctica. West Antarctica in particular and Greenland have started changing their behavior, and they've doubled the amount of ice that they're dumping into the ocean. They're these huge glaciers that drain the ice sheets, just like rivers. They move much faster than the rest of the ice sheets, have doubled their velocity over the course of the last 15 years. In large part because they're probably lubricated at the bottom, but also because sea surface temperatures are warming up and melting the ice shelves. So we don't know if that's going to speed up, stay the same, or slow down. We don't have good models to tell the public decision makers what's going to happen. And as a result, there's a huge range on how much sea level is going to rise. What's interesting is that over the course of the past 10 to 15 years, the range has never got lower. Right? The bottom part of the range increases a little bit, and the top part of the range increases a lot. So the message here is, sure, there's uncertainty, but it's not going to be any less than a foot by the middle of the century, and it's not going to be any less than a couple of feet by the end of the century. So time to start preparing for that. Right? We do not have the money to protect all of the eastern seaboard from 2 feet of sea level rise in the next year. But we don't have to. We've got time to see actually what's going to happen with sea level rise, as long as we begin to lay the foundation for how we think about dealing with sea level rise. And my colleague Paul Kirshen, who works on coastal infrastructure, will say there's really 3 things you can do. You can protect it by putting up big seawalls, but they have their own challenges that you know about here in Newburyport. You can adapt, you can change your structure so you can adapt with higher sea levels, so you can put your building on big posts. For example, you can have a bottom foundation that knocks out but doesn't knock your house down. Or you can retreat. Or you can do a 4th thing, which is do nothing and stick your head in the sand and hope sea levels aren't going to rise, which isn't going to happen. And those are not easy decisions, right? Because these are people's homes that they've had for a long time. But it's a reality of the future, and how much longer can taxpayers keep paying for people to rebuild their houses in these areas? It's going to be a really tough discussion. I would suggest probably nowhere tougher than right here in this community. But this is, you have to start preparing for 1 foot by the middle of the century and 2 feet by the end of the century. And then see what develops as we move along. Science is going to get better at narrowing these predictions as we move forward in time. So yeah, that's just a sign to say, a big part of the uncertainty is what's happening with Antarctica and Greenland. But you can see in the blue line and the pink line that the sea level contribution is just continuing to get more and more and more. All right, so I just did this to show people in coastal New Hampshire what I'm talking about. Because 11 feet, 12 feet of tidal range, what's a couple feet of sea level rise mean? Well, the challenge is always when we have a really big storm, right? So those bars, this is actually the scale. This was probably as good for Plum Island as it is for Rye, New Hampshire. So there's low tide to high tide, 9, 10, 11 feet tidal range. Storm surge currently in coastal New Hampshire is about 8 to 9 feet. You add sea level rise by 2050, that's 1.7 feet. By 2100, you get up to that 6.3 feet. And then, you know, worst of all worlds, we have that big nor'easter that comes in on king tide, which in coastal New Hampshire adds another couple of feet. So you've now got still water coming in the second floor of somebody's house, right? So the problem is not the day-to-day sea level rise. Well, that has problems with it, but the big problem is when we have those big nor'easters that happen through astronomical high tide, and they end up eroding beaches and washing houses away. So just to give you a sense of the potential future, this is probably applicable here for Newburyport, but here's our 100-year flood height as measured in the Piscataqua River at our Adelgid that we have up there. That's the current 100-year flood, 6.8 feet above high tide. If you add sea level rise at 2100 and king tide, under higher sea level, right, that could be as high as 15.3 feet. So we're looking at more than a doubling of what the existing 100-year storm surge height is. So the maps I'm about to show you are for 12 feet above mean high water. All these numbers are for mean, above mean high water, which is sort of the average of the highest daily tide. So the maps I'm showing you are not the worst case scenario by a long stretch. And I picked one. I haven't done these for Newburyport or Plum Island. I would encourage you, I think, to pursue them because they're very illustrative. You might recognize this. So Seabrook and Hampton, the Seabrook-Hampton estuary, and back there you can see the nuclear power plant, right, back in there. And so we've done this a little differently. And what I'm plotting here is if there's a storm that results of an increase in sea level, 12 feet above mean high water. If you're in yellow here, that means the depth of water over the land is 0. The depth of water over land is 0 to 3 feet. In the pink, it's 3 to 6 feet. So here you better get your big hip waders, right? 3 to 6 feet, you got to start thinking about getting a boat. 6 to 9 feet in orange, right? You got to start thinking about getting a much bigger boat. And greater than 9 feet, like it's probably time to leave. So if you take a look up there at Hampton Beach, you can see that, so I need a sort of a pointer. Well, you can see here, let's look at Seabrook, right? This is a really big residential area in Seabrook. It's at a big berm, like you do in Plum Island, and it goes down into a bowl and back. Right? These homes, right, on the land, there's 9 feet of water. Tough to recover from this 100-year storm. Same at Hampton Beach, most of the businesses along the entire Hampton Beach are underwater. These are still water elevations. They don't capture the impact of any significant wave action. Right? The good news here is that our nuclear power plant isn't underwater. They built it high enough so that it should be good for a few more decades. Hopefully, I don't know what they've done with their generators, which was a problem with Fukushima. But, you know, when you think about the tax dollars for Seabrook that come from this set of homes that's along the beach, this would be devastating for the community, and I would argue would result in, I don't know how that community survives without the tax revenue from those homes. It's not a very different situation for Plum Island. Right? That level of sea level rise is really going to put most of those homes at risk. Similar map that we did for Portsmouth, New Hampshire. You're probably not as familiar with the geography up there, but lots of our downtown area that's currently being developed actually goes under sort of 3 to 6 to 9 feet of water. There's a historian looking at this map the other day saying, wow, all that stuff that's underwater, that's where people never built in the past. But the biggest concern when I look at these is that island right up there, because that's our Portsmouth Naval Shipyard, which used to be 3 islands, and it's now 1 island, which is why the Navy is all over the issue of climate change, because they've got a ton, right? Hundreds of billions, if not trillions of dollars of infrastructure at sea level. And we need to start thinking about what we're going to do with our naval facilities around the country. All right, so where do we go from here? This is all very depressing. And yet I remain optimistic. And I would argue that we are at that proverbial fork in a path in the woods. And the path that we've traveled is one where we just stick our heads in the sand and continue to rely upon fossil fuels as our main source of energy. And I would argue that we're really at the point where we no longer have a choice to go down that pathway. We have to go down a different pathway, where we invest in energy efficiency and renewable technologies, and in our communities we work hard, especially with our budgets, to figure out how it is we make our communities more resilient to the new climate normal. And I think another pathway, at least one that I've been thinking about most recently, another part of the path less traveled, is really what is it that we do with all of our investments? So, you know, I'm a climate scientist. I've known these problems been going on for 25 years, but I still put my retirement fund that goes up essentially smokestacks in China, right? I put it into the stock market, and it disappears, and it makes me a good rate of return, and I'm happy. But I'm no longer happy, because what I want to do is invest that money in my community. And there's a number of different new instruments and tools that are being developed to be able to invest in your community, but also have an instrument that can spread the risk over enough investment such that you make a great rate of return. I don't know about Massachusetts, maybe you guys have some examples, but in New Hampshire we have the Community Loan Fund that is doing a superb job at these investments. You give your money to the Community Loan Fund, they invest it, they do great community work with it, and their default rate is less than what the big banks is. And so because transitioning to be more energy secure and to be more weather resilient is going to take an upfront investment, I think we have to figure out a way that we don't look to our federal government to do this, because I'm daily losing faith in my federal government, especially to think about addressing big issues like this at a community scale. I think we're still going to be funding our military. I don't think that's a problem. But you know, where are we going to get the money to protect our communities? And I think we need to figure out how we invest in our communities and have those communities provide us with a rate of return on our investment. And I'm not an investment specialist, but I actually see this as the major barrier. We need to get that community money on the street to help make homes more energy efficient and to help communities adapt now so that we can save money in the future. So we'll just finish up with a couple of examples. A lot of my examples are from New Hampshire. You guys have a great climate action plan in Massachusetts. You actually have a law that codified that climate action plan and those greenhouse gas reductions into law. You're really leading the nation in that way. But really, climate action plans are pretty straightforward. You got to make your buildings more energy efficient. You got to do renewable energy generation. You got to protect your natural resources, right? You don't want to go and cut down all your trees for energy. And if you do want to cut them down for timber and some energy, you got to make sure you don't pave that land over. You got to let those trees regrow. We got to expand our agricultural production to improve our food security. We need government action, should lead, and we actually have to figure out at a community level, which you guys are grappling with, is how we adapt to the future. And so I think I'll just finish up a couple more slides here. This is true for Massachusetts. I put the New Hampshire slide up here. We're actually doing the right thing. We're reducing our greenhouse gas emissions while we're growing our gross state product. Now you could argue that's not the best measure. It's just an easy measure and one that's easy to get. But this separation of greenhouse gases and gross state product is exactly what we have to do. We're going to use energy. We need energy. You can't run our economy or support our quality of life without energy. We just have to get it without burning greenhouse gases. So you're going to increase the gross state product while you reduce your greenhouse gas emissions. That's exactly what we need to continue doing. And New England and California are really leading the nation in this respect. So we're already doing it. We just have to do it better. Per capita emissions of greenhouse gases, you can see Massachusetts is doing pretty well there. New Hampshire is not far behind. Given the amount of money, we spend a lot less money per capita than Massachusetts does, but we're doing pretty well and trying to keep up. But you guys, again, are leading the nation in a number of different aspects. So I'll stop there. This PowerPoint will be available to you. All of the resources that I talked about, the images I showed, is in one of those references up there. If you really want to dig into the climate science, you can check out these papers. Thank you, and I'm happy to answer any questions you might have.
Within the same year, you know, it's like every spring is going to be a flood and every summer is going to be a drought.
question's about the frequency of how can you have droughts and floods at the same time. And essentially, the droughts are always going to come in the summertime. And the floods are going to come in the other seasons. So think about our big floods, right? They don't occur in summertime because actually the ecosystems suck up all that water anyway. So March 2010, that was a spring, so March, early spring, rain on frozen ground. The 06 and 07 events, both April and May. You know, the worst case, which we can't even model, is that precipitation in winter is going to go up, as well as the shoulder seasons. But if we get an increase in winter precipitation, which we project, it's going to be warmer, so it's going to occur as rain. But there's no snow on the ground, and it's still cold enough for the ground to freeze. That would be the worst case, is that we have frozen ground, no snow cover, and a really big precipitation event, which is sort of what happened in March 2010. So yeah, droughts in summer, floods other time of the year. It's like it's like the definition of hell squared or something.
Won't that have a bigger impact than like you're showing the change in the forest? I mean that in of itself, the big cycle like that, I would imagine has a big impact on all the wildlife.
So yeah, it's huge changes in ecosystems and wildlife, but I don't think that's going to have a big driver on flooding, especially if we're getting rid of more of those ecosystems. And you know, the impacts on wildlife, that's tough. Wildlife, if you think climate's tough to model, wildlife dynamics, you know, like just the dynamics of Lyme tick disease are really difficult. But yeah, so I think there's certainly going to be some unknown consequences of what's going on. But I think for the flood story, we've got it pretty well nailed down. In that, especially if we continue to pave the watersheds, they'll be much worse. But yeah, droughts and floods increasing in frequency every year.
Given where we are right now, where we sit right now, 100 years from now, this building won't be here, no matter what.
I would say that's a reasonable conclusion, yes.
And the Audubon, and most of Plum Island Turnpike does not know Plum Island.
I mean,
We could go to that.
when it's not flooded, there'll be a beautiful estuary here. And they'll
But
put
if
sand
the sea
dunes out
level
there.
has risen 4 feet.
Yeah, there's nowhere really for that. I don't know the geography here. I know when we were talking to Seabrookhampton, Hampton Falls, we've talked a lot about one of their adaptation measures will be to, wherever they can, not develop land that's close to the salt marsh, so the salt marsh can move. My gut feeling is that here, there's not a lot of places for it to move. So I mean, it would. There's some areas where I think it could move inland. You know, driving along Route 1. So it's going to migrate, and where it has a place to migrate, it will migrate to. Where it doesn't have a place to migrate, those places that are hardened will be more at risk.
You're saying the salt marsh moves in because,
If there's place for the salt marsh to move in, yeah, and it's been moving. I mean, there was no salt marsh here 15,000 years ago, right? It's a recent phenomenon of sea level, which rose from 18,000 to 10,000 years ago, rose 400 feet. So they're a sort of a modern creation. Somebody's waving at me in back there.
Yeah, hi. In the current situation with FEMA, before the new regulations came out, I believe that in the flood zone or something, the elevations of new structures had to be 12 feet plus a foot above mean flood elevation. 12 feet is would you consider mean flood elevation?
Well, so so I need the details. I mean, talking about freshwater or ocean flooding, and talking about any, the vertical data, or about mean high water. So it changes depending on where you are. But 12 feet above the North American vertical datum sounds about right for coastal flooding where we are now.
Yeah, I think they added a foot to that as well.
Well, Massachusetts would have. FEMA hasn't.
Okay.
Or maybe if they've drawn new maps, they've done it. But FEMA's got a challenge because they refuse to look in the future.
We have a controversial project being proposed for the Newburyport waterfront right now. Commercial, residential project, 70,000 square feet. Within what's called Commonwealth tidelands, the tide historically flowed right up against Water Street. There's a law called Chapter 91 in Massachusetts. For the use of tidelands, you have to get a special license or a permit. And the current laws, regulations say that you have to take into consideration 3-foot sea level rise over the lifetime of the project, which they estimate to be 75 years for a typical project. What would the implications of having to raise the base elevation of a structure by those 3 feet? Do you have any? Is it currently the people that are proposing the project are ignoring this particular fact?
So you can't let them ignore it.
Well, we're hoping to
but you
force
just
them to
can't.
recognize
Right.
it, but they're unwilling to recognize it and are putting off recognizing it until after they make a decision about granting someone permission to do it.
Right, so forcing them is a social problem, and so I can't. I'm a climate scientist, but the ramifications are, I would say, significant for the cost of that structure to actually raise it 3 feet. But there's plenty of examples, especially if you go to Germany and the Netherlands, of companies that have done exactly that. They have actually their bottom, they have street levels that are essentially a level above the street, and their bottom floors are for parking. They don't build swimming pools to put their parking in. The bottom is for parking so you can move all those cars, etc. And then they have where they walk actually, and their terraces, etc. One story up. And so there's plenty of examples, and I have a friend in Portsmouth who called me up 6 years ago. He said, "Cam, I'm building a new house. What should I do?" I said, "Raise it 3 feet above the height that anybody tells you to do it." And he did, and he didn't put any of his heating or air conditioning in the basement. He put it on the first floor or the second floor. They just built a hospital in Boston that did the same thing. So short term, the ramifications are it's going to cost more. Long term, it's going to end up making that facility have a much longer lifetime. And so if I so this is, I'm going to give you some social advice from a scientist, so just take it for what it is. But I would really be asking the question, who's paying the insurance? Who's paying for the insurance on this building? And I would wrestle a guarantee from them that not a cent of taxpayer money goes in to insuring that property year to year, or for rebuilding it when it gets destroyed. We cannot continue to push public money into private buildings, which is the National Flood Insurance Program is bankrupt. It's bankrupt by billions of dollars, and so now we're changing the floodplains, and it's going to cost people a lot more for flood insurance, and families are not going to be able to live there. It's already happening in New Jersey and New York. I heard some examples from up here on Plum Island. If you can't get them to be aware, just ask about the insurance question and say that you're not going to bail them out. It's your building, you take care of it. Don't ever come back to us and ask for money to fix it. At some point, you need to get them to understand that it's in their best interests to actually take into account sea level rise. And so I'll tell you, this is getting me going on social stuff. You know, I got to tell you, the people that resist the issue of climate change the most seem to me to be people who have made lots of money in their lives and think they know it all. They're in charge. I get told about climate science all the time by wealthy individuals. It's like, I study this stuff. I studied it for 25 years. I can't emphasize enough, you have to get through, especially to developers. And if you can convince them that they're going to make more money if they pay attention, that's the corner that we have to turn.
On top of that, we're talking about underground parking structures.
Just start calling it an underground swimming pool. Just start referring to it as the Big Dig. That's a really expensive swimming pool. I don't want to swim anywhere near those tiles. Yes. Sorry, the woman behind you first. She was faster to the draw.
So being on a positive point here, you said you're optimistic about this.
Some days.
Well, putting it back for all this, what are some of the clean energy technologies or projects or initiatives that you see locally in New England that
the above. You can't really solve it with any one technology, so it's all the technologies. But the one that is the biggest and the most effective is actually energy efficiency. In Germany, they use half the amount of energy we use, and they have a similar quality of life and economy. So, I don't know about Massachusetts, but New Hampshire, we have 500,000 homes, and about 500,000 of them are energy inefficient. So, we got to renovate those, and that's a great workforce development program. We just got to get on and do it. And then certainly wind there's wonderful opportunities for wind. We have to solve the problem on where to site it, so we don't have all these not in my backyard fights. But we have to come out in a big, open, messy public discussion and say, this is where wind's going to go. Where is that going to be? I'm not the person that's going to dictate it, but Maine is investing in a huge way in offshore floating wind. Huge amount of money going in to develop that technology, and there is no shortage of energy. They're talking about powering New England with offshore wind in Maine in the future. Wind's good. Solar, there should not be a building in New England that doesn't have solar hot water. 9 months of the year, we can generate most of the hot water we need. It's cost effective. It pays for itself in 4 to 5 years. We should just be doing that. And then, frankly, photovoltaics work. We just have to have better net metering laws so that whenever we're putting it into the grid, we're getting out of wholesale and get a retail price for that, which means it gets subtracted from our bill at par for when we're using energy. So it's not going to solve all our problems, but again, Germany, not a sunny place, right? Solar leader. Clearly, we have biomass across New England. I don't think we should cut down all our forests, but we shouldn't be using those forests to generate energy that's really electricity that's a very inefficient process. So 25% efficiency when you take wood chips and burn them for electricity. 70 to 80% when you burn that as heat in your home. Better than that if you have a wood pellet stove. So wood for thermal heating or district wood heating, that makes sense. And then the big technology leap there is we might be able to get cellulosic ethanol. So we have to get the bacteria right, we have to figure out how to do this, but how do we get liquid fuel out of our trees? Geothermal, lots of opportunity for geothermal across the Northeast. It's expensive to retrofit for new buildings, we should be doing it. And then sort of on the cusp, not quite there, if I had a lot of money to invest, like billions of dollars, I would be investing in ocean energy, tidal and wave energy. We've been talking about it for 20 years, but we're not going to be doing big algae ponds in New England. They're going to be happening in California and Arizona. But ocean energy, I mean, you've all stood out there on that ocean and seen the energy, right? There's a lot of energy. We just haven't figured out how to harness it. Did I miss any? That's pretty good.
You showed an image going down in a, whatever was the use of, the energy, basically become more efficient.
Per capita emissions of greenhouse gases. Yeah. Per capita emissions are going down, but population's growing. We've actually, the major driver has been more expensive fuel oil. We've been getting a little bit more efficient. I think there's a price signal there that's been driving that. But we've also had a whole bunch of different programs, right? And we turn our lights off a little bit more. And probably a big driver is the expansion of the Regional Greenhouse Gas Initiative, which has forced companies to reduce the amount of carbon they emit per kilowatt of energy generated.
I guess my question, hypothetically, if I had a home or a business in a place like Plum Island, why would I want to put money into solar and or be concerned about mitigating carbon emissions? Would not want, everybody has limited capital, limited resources. We want to put it into mitigating the effect of climate change. Build your house like you suggested up on piles and putting a big seawall in. You can't solve this problem locally. It's really global. You can put in all of the solar and wind you want here in New England, but if they're not doing it in Ohio, in India, in China, in Russia, in Africa, you're totally wasting your money. You should go put the money into mitigation of the effects of climate change.
So, great point, but I'm going to disagree with half of it. So on one point, so we don't use the word mitigate for both in the climate work. So we use mitigation as reducing greenhouse gas emissions, and adaptation is responding to climate change. Except FEMA uses the word mitigation for adapting to climate change. But I'll stick to the adaptation and mitigation separation. So with that said, the most effective adaptation strategy is to reduce greenhouse gas emissions, to reduce the amount of change that we need to adapt to, so that we adapt to 2 feet of sea level rise instead of 6 feet of sea level rise. So then the question is, if you agree with that premise, then why act locally when it's a global issue? So the real reason to act locally, I'd agree with you, is that actually you want to reduce greenhouse gas emissions because the way we get there is how we become more energy secure. So we are not sort of at the beck and call of global energy markets. We should think of it being independent Yankees with the energy that we produce, and that's going to be really good for our economy. Right, well, it's a different reason, but it solves the same problem. So the second part of that is, we know that most of the carbon in the atmosphere comes from the developing world. That carbon morally belongs to the developed world. It's not the developing world that has put it there. The problem we are in today is because of the developed world. The problem 50 years from now is going to be that of the developing world. So I would say we're morally obliged to act. And as a result of that, we know that China and India will not act unless the United States acts. Europe has taken a leadership role. The United States has not. And so China will continue to drag its feet, as will India, Brazil, and Indonesia after it, if the U.S. does not show some leadership on this issue. That I am certain of it. So why can't New England, well, and California, be the leaders of this country? So the reason we do it is because we figure out how to do it, and then we help the developing world develop on a pathway that is fundamentally different from the pathway we developed on. So that's how I feel you solve the problem, is that actually the U.S. is in this critical role. And the other piece is that I just don't buy this, well, if we don't do it, if India is the problem. Since when has the United States looked at a serious global problem and said, yeah, we don't want to lead on that, thanks. Right? We pride ourselves on being a global leader, so why not lead on this issue? I do not understand why we don't take that position. Now, the other part of your question is an individual living on Plum Island. I think there's a point there, because I think in the not too distant future, those houses aren't going to be there. So I would invest in, frankly, I would invest in a property somewhere else. I understand that's difficult, and I'm not trying to be funny. But if I was sitting down with my family and I had a place on Plum Island, I would say, who can I sell this to tomorrow? Or can I afford to just accept that it's going to be washed away at some point in time, and I will no longer have it, and where will I go to live? And I would not be putting a bunch of solar panels on it or fixing it up. I would be figuring out a way that my family could afford to leave it.
Another problem you're going to run
And I don't have that problem, so maybe that's easy for me to say. I know that that comes with a lot of pain for a lot of people.
Another problem that you may run into is that you may retrofit your home, but if your neighbor and the town doesn't also raise the streets, you're going to be sitting in a house that may be out in the water.
So absolutely. So you have to make that consideration of, do you want to spend a bunch of money on a house that is likely going to flood in the future? And that's another tough decision, and I would say you probably don't. You certainly don't want to move to Florida either. Rent. I tell my students, I say, do not let your parents buy anything in Florida. Rent it, enjoy it while it's there. But they're, they don't have any elevation.
The scariest thing that you said here tonight for me was the inertia that the temperature rise is developed, that it's going to be 80 to 90 years or so before we see a change, pretty much despite what we do.
Well, 40 to 50 years.
40 to 50.
Yeah, middle of the century we begin to see that bifurcation.
you see results. But to have 2 to 3 generations of doing this and not seeing any results, that's going to be a pretty hefty visit.
Yep.
That's going to be, and I don't know about other countries. This country's not very good at it.
No, and
That's amazing. I had never realized that the lag time was that large.
And so there's a huge social and cultural challenge in a society that really looks to the immediate gratification. And we're not talking quarterly profits here, right? We're talking about 2 to 3 generations in. I think it's one of the reasons that we haven't been able to deal with this problem. I think secondly, it's been pretty easy for those who stand to benefit from the status quo. Big energy companies, for a while the auto companies, but not anymore, have been able to bamboozle the American public. They've had $100 million plus marketing campaigns saying, you're really good the way you are. Your life's fine. Don't worry about those guys talking about climate change. It's way easier to sell you're okay the way it is than you need to change. The flip side, I would say, is that climate scientists are really not good marketers, right? We've been started sort of 20 years behind, and it's not really our job to market. It's our job to sort of tell the truth as best we understand it. But it is one of the cruxes of the problem, and the one place, the 2 places actually that I think that people think really long term are their children's education and insurance that they buy. And so I think those, for me, are the 2 examples I can bring up. That this is about investment in the future of your children. It's not about us. And in fact, our generation, I think I can say that, I would say we have completely failed our children and grandchildren. We have kicked the can down the road, essentially so that we could have a better quality of life. And we really, the way we act suggests that we don't really care that much about their collective future. We obviously care about our kids and our grandkids and their individual future, but collectively we're not acting like we care about the future.
I was just wondering, as a climate scientist, what do you think about nuclear energy and natural gas?
So nuclear, there's certainly several climate scientists, James Hansen among the most prominent, who said we got to get going on nuclear. It's the only way we can solve this problem because I don't see humans changing their behavior. He argues that there's a whole new set of nuclear power plants that are coming out that are much smaller and much safer. So I'm not a nuclear scientist, so I don't know. But certainly the current system, I think we cannot go down that pathway because not only because of the fact that there's problems with the nuclear power plants as they are just with tsunamis and tidal waves, but certainly there's a whole terrorist aspect to it. But the most concerning for me comes back to, because I actually study this, and it's the economics of it, right? Just like you have to get our flood insurance from the federal government, right? Nuclear power plants cannot pay the insurance on their facilities. That insurance is paid by you and me. And therefore, it's an economic model that is not sustainable unless we want to keep holding the bill. So I come from Canada. I'm actually a social democrat, right? You can call me socialist and I don't get upset about it. But I'm becoming more and more of a libertarian in that I don't think there should be subsidies for energy. Like, let's just open it up, get rid of the subsidies for big oil and big gas, and let's just see who wins. Because we have subsidized nuclear. I mean, when I was a kid, do you remember this? Energy will be too cheap to meter. Right? Not so much. And so I don't think nuclear, as it is today, is an answer. If we can come up with something that's much safer, and therefore plants that can insure themselves and deal with this whole terrorist threat of the waste, maybe, but not as it stands now.
How are we doing for we all?
I think we have time for one more, and it has to be quick.
Okay.
Wow, tough. I don't know. Who's got it? You guys fight amongst yourselves. You had one already.
I have one.
All right.
So my question is that one of the things we have a lot of discussion about here is mitigation strategies like seawalls and beach scraping and things like that. And they cost money. They protect things for the moment. What's your take on those things?
as you have seen with your own eyes, it's a very short-term solution. And when you're desperate, you will certainly invest in short-term solutions. So I think at least a part of the conversation is, so what are we going to do this year? But what are we going to do 10 years from now? What are we going to do 20 years from now? What are we going to do 30 years from now? That needs to be part of every discussion that a family has, that a community has, that the state has, and that the nation has. What does climate change mean for this decision? And I don't have all the answers, but we need to start having the adult conversation. Not saying, wow, we don't have to worry about it. We have to worry about it. And if we start now, there's enough sort of money in the public realm that we can begin to do things over the long term that will build community resilience. And they're going to be difficult decisions, but we have those financial resources over decades. We don't have them in 1 year. That's why we have to plan.
Well, I'd like to thank Dr. Cameron Wake. You did a great job.
The PowerPoint, so if you want to see the slides, you guys can put it up on the Storm Surge website.
Yeah.
Good luck with all your work going forward.